Hey there, I'm TJ Van Tol, and I'm a Principal Developer Advocate at Blues. This video is the first in a series I'm calling Building a Connected Product with Notecard. In this series, I'll sequentially go through all the steps necessary to build a production-ready connected product. This series is aimed at users that have some experience with Blues Notecard and are looking to take the next step and build a serious project with Blues tech. That being said, if you're new to Blues, you should still be able to follow along, and you'll definitely learn a lot about how Blues Notecard and Blues NoteHub work along the way. This is a 5-part video series covering everything you need to know about hardware, firmware, and what to do with your data once your devices are in the field. As we go through the series, we'll be building 2 different products together, based off real use cases that have come up at Blues. These products will help me demonstrate the various recommendations I'll be making. The first product we'll build is an air quality monitor. This will be a solar-powered outdoor device that will take periodic air quality measurements and synchronize them to the cloud. For this project, we'll leverage the low power nature of Notecard so that our device will work outdoors and last essentially indefinitely on solar power. The second product we'll build is a vehicle tracker. This tracker will use Notecard's integrated GPS module to take and report regular location readings. We'll also use a host microcontroller to monitor the temperature and humidity of the vehicle, and to use Notecard to send alerts if something looks off. And as I was planning out this series, I realized these projects would be a lot easier to talk about if they had names. So with a little help from AI, I came up with AirIQ for our air quality monitor and Temprak for our vehicle tracker. All right, now that we know about the products we'll be building, let's return to this video's main topic, hardware. When you build a Notecard-based connected product, there are a few basic hardware components to consider. The first is Notecard itself. Notecard is a connectivity module. It enables wireless connectivity for your system over a number of different radio access technologies. To use a Notecard, you must have our second hardware component, a carrier board. A carrier board is a circuit board that provides the power, connectors, interfaces that you need to support your project. At a minimum, a carrier board in a Notecard-based project must provide a way to house a Notecard and to power a Notecard as well. The third hardware component is a host microcontroller, or just host. The host acts as the brains of your project. In Notecard-based projects, the host is responsible for reading sensor data, communicating with peripherals, queuing data on Notecard, and interfacing with any user input your system might have, such as buttons and that sort of thing. And all right, now that you have an overview of the hardware components themselves, we'll spend the rest of the video taking a closer look at each component in a bit more detail, with a focus really on how to pick a Notecard, how to pick a carrier board, and how to pick a host. Our first topic is choosing a Notecard, which can seem simple, but there are a surprising number of Notecards to choose between. When selecting a Notecard, the first thing to consider is what radio access technology, or RAT, that you want to use. At a high level, there are 4 different types of Notecards: cellular, Wi-Fi, Cell Plus Wi-Fi, and LoRa. Cellular Notecards are the most commonly used Notecard and provide cellular connectivity in really just about any location that has cellular service. Wi-Fi Notecards connect to a 2.4 gigahertz Wi-Fi network and work well for any project that will have a reliable Wi-Fi connection available like 100% of the time. Cell Plus Wi-Fi Notecards allow you to connect to a Wi-Fi network, but to use a cellular network as a backup in case your Wi-Fi network goes down or in case your device leaves Wi-Fi range. And then finally, LoRa Notecards work on the lower bandwidth LoRaWAN protocol and must be in range of a LoRaWAN gateway. LoRa-based Notecards are a great fit if you need to deploy lots of devices in a small area, or if you're in an area that has broad LoRaWAN coverage already. At the time of this recording, Wi-Fi and LoRa Notecards are the cheapest at somewhere around $10 each. Cellular Notecards are $45 to $55 US, and Cell Plus Wi-Fi Notecards are around $55 to $65. You can always check shop.blues.com if you want to see up-to-date pricing on all Notecards. To put this all in context, let's look at the radio access technologies we want to use for our projects. Our first product, AirIQ, is an outdoor air quality monitor. Because AirIQ is an outdoor device, it might not be installed in range of a Wi-Fi network, so we are going to want this project to have cellular coverage. Now, we could use a cell plus Wi-Fi note card for AirIQ. If we did that, we could do something like have the owners of an AirIQ device add their Wi-Fi credentials and then sync data over Wi-Fi when it's available. But there's not a lot for AirIQ to gain by doing this. AirIQ also doesn't have a lot of data and doesn't require any sort of low latency. So we're going to stick with a cellular-only note card for AirIQ. Our second project, Temprak, is a tracking device. So it'll absolutely have to work on cellular networks. That's really the only option. However, I am going to use a cell plus Wi-Fi note card for Temprak, as I want to use Wi-Fi triangulation, which is a feature of all Wi-Fi-based note cards. I'll explain a bit more about what Wi-Fi triangulation is and why I want to use it when I talk about note card configuration in the next video in this series. But for now, know that we will be using a cell plus Wi-Fi note card for Temprak. All right, so now we know we want to use cellular-based note cards for each project. But we're still not done, as even within the cellular category of note cards, we still need to choose between wideband, midband, and narrowband note cards. Wideband note cards run on LTE Cat 1 and have the highest data rates, best coverage, and lowest latency. But they also require the most power and are the most expensive modules. On the other end of the equation, narrowband note cards run on LTE-M and NB-IoT and are the cheapest note cards, and they also use the least power. However, we at Blues have had a lot of customers and users that have struggled with the connectivity on narrowband, and so in general, we tend to steer our users away from narrowband note cards unless they know that they have really good LTE-M coverage in their deployment area. Finally, midband note cards run on LTE Cat 1 Biz and really provide a nice middle ground between wideband and narrowband note cards. They have more reliable connectivity than narrowband note cards, while also providing data rates that are sufficient for the majority of connected products. So what does that mean for our projects? Well, returning to them, a midband note card is really perfect for AirIQ. AirIQ is a low bandwidth project and it'll be running on solar power, so it needs to be low power friendly. But we do want to have reliable connectivity, as we expect AirIQ devices to be installed really all over the country, maybe even all over the world. So we will want to stay away from narrowband. For Temprak, though, we will use a wideband note card, as we want these devices to have the best possible coverage, both because Temprak devices are on the move, so they'll be going into areas with bad connectivity, low connectivity, and also because I want to send out alerts for this project. For example, when the temperature gets too hot, I want to send out an alert for that sort of thing. And what I really do want those alerts to go out as fast as possible, and wideband note cards are going to give me the best connectivity for that. Wrapping up this section, this means that we will use a midband cellular note card for AirIQ and a wideband cell plus Wi-Fi note card for Temprak. I'll also be using the North American version of each note card because I'm located in North America, and generally speaking, the region-specific note cards are cheaper than the global note cards. That does mean I'm limiting my deployment area for each of these projects, but that actually brings me to one final point I want to make about note card selection. Because all note cards share the same form factor and M2 edge connector, it's really trivial to switch between note cards. So if you start prototyping your devices and realize you want to switch from midband to wideband, or maybe even from cellular to Wi-Fi even, you don't have to throw out your entire design. You just unplug your old note card and slot in your new one. So if AirIQ and Temprak take off, they're wildly successful, I'm a multi-millionaire or whatever, I could start buying global note card versions so that I have a greater coverage area, and I could switch to them without changing my hardware design or firmware in any way, which I think is really cool. Before we leave the topic of choosing a note card, there is one final thing I want to discuss, and that's satellite. At Blues, we offer satellite connectivity through our StarNote for Skylo product, which is a note card accessory that allows you to sync data over Skylo's geostationary satellite network. StarNote for Skylo is a low bandwidth solution, like a very low bandwidth solution, just because of the very nature of satellite networks themselves. Just to give you some idea of the bandwidth restrictions, we're a cellular-based note card. Those come prepackaged with 500 megabytes of cellular data. A StarNote for Skylo comes with just 18 kilobytes of prepackaged data, so not much. For the right projects, StarNote for Skylo can be pretty revolutionary though. I mean, even though the product is low bandwidth, it can allow you to send data and receive data in a way that just quite simply was not possible before. That being said, anytime you introduce satellite connectivity, you do introduce more complexity for your projects. That's complexity in your hardware design, as you now have an additional component to work with, as well as some extra complexity in your firmware, as you now have to manage your data in a low bandwidth setting. Because of this, I only recommend using satellite if satellite connectivity is mission critical to what you're building. Now, that's advice as of May 2025. The satellite space is improving rapidly, so that advice might change as satellite modules improve. We're building our projects in 2025 though, and so even though satellite connectivity would be kind of a cool feature to add to AirIQ and Temprak, it's not mission critical for either of those projects, so I am going to be skipping them for these two, at least for now. All right, returning to our agenda, let's next talk about carrier boards, which you'll recall is the circuit board that connects the various components of our device. Now, it's quite common to use multiple carrier boards while developing a project. The common workflow that we see here at Blues is that people use a development-friendly carrier board while they're prototyping and initially trying out whatever it is they're building, and then they'll switch to an optimized, custom-built carrier board as they start to scale their projects up to hundreds or thousands or however many devices. For this video, I'm going to help you choose a carrier board for prototyping, and then I'm also going to give you some tips on moving to a production board when you are ready to scale up. At Blues, the prototype-friendly carrier boards we provide are called note carriers, and our most commonly used ones are the Note Carrier A, Note Carrier F, Note Carrier Pi Hat, and the Note Carrier X series. All Blues note carriers expose a note card's pins and provide a port for powering a note card through a USB connection. From there are differences though. The Note Carrier A has onboard cellular and GPS antennas, and using those onboard antennas can really be convenient because the antennas are on the board itself, so you don't need to hassle with an external wired antenna. But using the onboard antenna isn't an option for every deployment. If your device is going to be something like near metal or anything that might interfere with signal, using that flexible antenna and putting it away from whatever might interfere is going to get you the best signal possible. But if you know your deployment is going to have pretty good signal available, the onboard antennas can work just fine. I use mine here in my office all the time, and personally I haven't had any issues. And then lastly, the A also has 2 quick ports for connecting sensors and peripherals, and JST ports for providing power. The Note Carrier F provides header sockets for connecting Feather-compatible microcontrollers. The Feather form factor is a popular hardware standard. It was created by Adafruit, and you can find a number of different host microcontrollers that share the exact same Feather pinout. The Note Carrier F handles all the wiring between the Feather host and your note card, which is pretty handy, and also exposes the pins from both the note card and your host in header rows. And like the A, the F also provides both quick and JST ports as well. The Note Carrier Pi Hat, as is likely obvious by the name, is a hat that we make specifically for Raspberry Pis. The Pi Hat does have 2 quick ports, but no JST ports, as when you're using the Pi, we assume note card will be getting power from the Pi itself. Finally, the Note Carrier X series are our cheapest and smallest carrier boards. The Note Carrier X is just a $10 board that has a single quick port and a single JST port for a LiPo battery, and an eSlav port for certain types of Arduino devices. The Note Carrier XM is a $5 board that provides only a USB-C port for powering a note card. So which board should we use for our projects? For AirIQ, the Note-Carrier X is a great fit. AirIQ is going to need to run on battery power, so we are going to need a JST connector, which the Note-Carrier X has, but the Note-Carrier X does not. The X is also a good fit because we want as small of a carrier board as possible for AirIQ, because as you're going to see in a second, hopefully we'll be able to fit it into a fairly small enclosure. For Temprak, the Note-Carrier F is a good fit. The F is a bigger board, but since this is going in a vehicle, I'm less concerned about size. And just in general, the F is my personal favorite prototype board because not having to wire up a host just makes it more convenient to get set up, move the device around, do what you need to test things out. Especially when you're testing a tracker, a lot of times you just want to kind of pick it up and go. And just having the F for that with less wiring makes that process a whole lot easier. So those are our boards for prototyping, but what about production? When I'm dealing with a few or even dozens of devices, Note carriers are super convenient and make testing a lot easier. You're going to see that here in this video series. But if you get to the point where you are making hundreds or thousands of devices, that's when you probably want to look into creating an optimized version of your carrier board that has only the components that you need. This is going to make your boards smaller and also just more cost effective. If you or your company has the expertise to design boards like this yourself, we strongly recommend you take advantage of a service that we offer at Blues called MinSpin. With MinSpin, you submit your board designs to experts here at Blues, and we'll give you back recommendations based off our expertise with other customers and users that have built boards around Notecard. MinSpin is actually 100% free, so I really highly recommend checking out and using it if you get to the point where you are creating your own custom board designs. If you or your company, though, does not have the expertise to design carrier boards, we can still help you out. At Blues, we work with a large number of partners, and many of those specialize in creating these sort of optimized boards for your projects. So if you don't have this expertise yourself and are looking for help, you can reach out to one of our partners or just contact us and we can help connect you with companies that our customers have been successful with in the past. All right, so that's carrier boards. Next up is choosing a host. Almost all Notecard projects require a host microcontroller. The host acts as essentially the brains of your project. In Notecard-based projects, the host is typically responsible for communicating with sensors and taking those sensor values and queuing them on a note card. When picking a host, the first thing to know is virtually every host can work with a note card. To communicate with Notecard, all you need to be able to do is to communicate over serial or I2C, which essentially every host you can buy can do. Because of that, my first host recommendation is if you have a host you're comfortable with and like using, I'd start with that. Especially in the prototype phase, the specific host you use isn't going to matter all that much. So having a host you're comfortable with and know how to configure is going to help you get your devices out in the field for testing faster. My other recommendation is to use a host that works well with Notecard outboard firmware update. One of the most powerful features of Notecard and NoteHub is the ability to update host firmware over the air. This feature is mission critical for embedded projects, and Notecard outboard firmware update makes the process incredibly simple. You'll see it in action in a later video in this series. Now, all STM32 and ESP32 based hosts work great with Notecard outboard firmware update, and some Nordic boards are also supported. If you're not sure about your board, I have a link to the firmware update docs in this video description, so you can check that out. For our projects, AirIQ and Temprak, we're going to use the Blues Signet for both. Signet is an STM32 based board, so it works really well with Notecard outboard firmware update. It's a feather board, so it's going to fit nicely into the Note-Carrier F that we'll be using for Temprak. And finally, it's a host I'm familiar with. It's my go-to board that I have workflows for and that I know very well. And when we cover firmware in this series, I'll be showing some of that off in action. Hey there, TJ from the future chiming in with one quick correction. For AirIQ, I'm going to be using a Blues Swan instead of a Blues Signet. Swan is a very similar board. It's also an STM32-based feather board, and it also works great with Notecard outboard firmware update. The only reason I'm using Swan instead of Signet is we sell the Swan without attached header pins, and for AirIQ, space is going to be at a premium, so I needed a host without the pins. And that's it. So there's that one quick correction. Let's go back to the video. And at this point, we've covered the main hardware components that make up a Notecard-based product. So as a next step, let's switch over to my bench and do some assembly. Here, I have all the AirIQ hardware. For our main components, I have a mid-band Notecard Cellular, a Note Carrier X, and a Blue Swan. I also have a PMSA 003i air quality breakout from Adafruit, which is the sensor we'll be using to get the air quality readings that drive this project. We'll look at the specific types of data coming from this sensor in a later video when we work on firmware. To house all of this, I have a solar power enclosure from Voltaic. What I like about this enclosure is it has a built-in LIC, or lithium-ion capacitor, that nicely connects to a Note Carrier's JST port, which I'll show you in just a second. I have links to all of this hardware in this video's description if you want to purchase any of these components to follow along. To connect everything, I'll start by inserting my note card into my Note Carrier X's M2 connector and screwing my note card in. Next, I'll attach this dual antenna that comes with the note card into the device's main and GPS UFL connectors. After that, I next want to wire my note carrier both to my Swan microcontroller as well as my air quality sensor. To do that, I'm going to use two quick cables, one to connect the note carrier to the sensor, and the next to connect to my Swan. The nice thing here is that the order you connect these components doesn't matter, as they'll all be on the same I2C bus. Finally, for power, when I'm ready to deploy this device, I'm going to connect the LIC on my enclosure to the JST port on my carrier board. The enclosure takes care of the solar wiring for me, so that's actually all I need to do. As our solar power gathers energy, it'll automatically charge the LIC, which will provide plenty of power to keep our device running indefinitely, as long as we put this enclosure in a location that gets enough sunlight. And that's where I'm going to wrap this up for now. I'm not going to put all of my components in the enclosure quite yet, as we still need to configure our note card and write some firmware for our host, and that's going to get a lot more difficult once we shove everything in our enclosure. So this is where we're going to leave AirIQ for now, so let's next look at our second project, Temprak. For Temprak, the main components we're going to use are a wideband Cell Plus Wi-Fi note card, a Note Carrier F, a Blue Signet, a 2000 milliamp LiPo battery, and a BME 280 environmental sensor that can take temperature, humidity, and barometric pressure readings. And the assembly for this device is pretty simple. I'll start by again inserting my note card into my note carrier, in this case the Note Carrier F, and then I'll attach the dual antenna to my note card. After that, I'll connect the Signet, which is pretty simple as all I need to do is slot it into the carrier board's header sockets. Next, the BME 280 sensor I'm using has a quick port, so I can again connect the sensor with a quick cable. And finally, for power for this project, I'll be using a LiPo battery, which is going to power this device when it doesn't have a USB connection. Most Note carriers, including the Note Carrier F, have a charging circuit built in, and that circuit automatically charges a connected LiPo battery when the Note Carrier is receiving USB power. So when you want to recharge your LiPo battery, all you need to do is plug your Note Carrier in. And we're going to call this project good to go for now. Also, before we take this one out in the field, I am going to want to secure this battery and this sensor, but we'll worry about that after we get our note card configured and firmware written, which actually is a good segue. In this video, we looked at the various hardware considerations that go into building a Notecard-based connected product. We looked at how to select each of the main components that go into a connected device: a note card, a carrier board, and a host. We then looked at examples of how to make those selections with 2 sample products we'll be building throughout this video series. Now that we have our hardware connected, in our next video, we'll look at how to configure a note card for a production-ready product, and then how to apply that configuration for both AirIQ and Temprak. If you have any questions about what I covered in this video, feel free to reach out in the comments or to ask in the Blues developer forum at discuss.blues.com. Thanks for watching, and I'll see you in the next video.